This is AQA 2018 paper 2. So this is the AS level paper. So this is going to be pure and stats. I actually recorded this video a while ago, but I just completely forgot. I'm sorry, not recorded it. I actually like made the slides and everything a while ago, but I completely forgot about it. So that's why this has been posted such a long time after paper 1. Anyways, I'm doing it now, so yeah. We just want to find y. So to find y here, we just need to integrate this because then it cancels this. So you can write this as 1/6 x to the -2, like this. And then if you just integrate that, that's going to be just increase the power by 1, divide by the new power to get this, and then do plus c, obviously. And then this here, this x to the -1, you can just bring it down here to get this, and then that's just this answer here. So we've got these four figures. Oh, and this one actually. Figure 1 shows y equals f of x, which figure shows y equals f of 2x. So f of 2x, if it's inside and it's a 2, it's going to be squishing it in by factor 2. So if we look at these ones here, none of them squish them in factor 2 apparently, except for this one. So it just must be figure 3. Expressed as a single logarithm. Bring the 2 up here, 6 squared, and then just because they're taking away logs of the same base, you can just do this over this as a single log, and then that's just log 12. Solve this given all solutions. Just bring the 3 to the other side, and then just square root both sides. But be careful, it's a plus or minus, because you have 2 solutions. So 2 theta equals 60 degrees, or 2 theta equals minus 60 degrees. What I've done here is I've added a plus 180 degrees k because that's how often it repeats. And then I've divided by 2. So careful. Make sure to put this on after before dividing. I made a video on this, by the way. You just watch it if you're unsure. And then just pick different values for k, making sure it gives a result of theta that's within that range. You get these ones. So when k equals 0, 1, 2, or 3. Same thing for this side. Here, exact same thing. Just plug in different values for k to get these solutions, and that's everything. F prime of x is this, and f of 3 equals 2. Okay, so I think I just expanded this. Yeah, I just expanded that. Okay, and then I integrated it, so just to get f of x. So increase the power by 1. So this is going to be 4/3 x cubed minus 12x minus 9 over x plus c. And then f of 3 is 2, so just plug in 3, and then you'll get minus 3 plus c, and that equals 2 apparently. So that means c equals 5. So just plug it back into there and you get f of x. We've got a rectangle with these points. Just draw on a diagram. It looks something like this. You know how to do this. If we have a look at the line AB, if you calculate the gradient of that, there are actually lots of ways that you can do this question. This is just the way that I did it. So I said that the gradient of this line is going to be -1 take away -7, so it's -1 plus 7. Okay, divided by 8 minus -7. That becomes 2 over 5. Okay, and then I've said that this line here, y equals mx plus c, plugging in m as this, and then I've just plugged in one of the coordinates. It doesn't matter. Eventually you'll get this for this line here. Now this line here, or even this one maybe, is going to have the negative reciprocal gradient if it is a rectangle, because it must have 4 90-degree angles. So yeah, it'll be -5 over 2. Okay, x plus k, some other y-intercept. I plugged in this point here, so we know it's this line, and you'll get this. So you've got this line here, and now you've got this one here. And then what I've done is I've plugged in this coordinate here to show that it goes through this as well. Run through that, you'll get 6 equals 6. Therefore, it does pass through D. Okay, so I've shown that the reciprocal of this line, negative reciprocal of this line, passes through D. Okay, and then I'm going to do basically the exact same thing. Okay, so we've got this line here. And now I'm going to pass it through this point here. So we've got this new line. Okay, so just evaluate that, you'll get this. Okay, and then I'm going to show that passes through C, so just plug in 4 and 9. You'll get 9 equals 9, so it passes through C. Okay, and then the line DC, just 9 take away 3, 4 take away -11. You'll get 2 over 5. So it's parallel to AB because that has the same gradient. Okay, and then one thing else that I actually should have done, I think maybe, is I think I just forgot to include it. But another thing that you could do is work out the length of this line here, and then the length of this line here, and show that these are equal, and then work out the length of this line here, and then this line here, show that these are equal, but also show that they're different from this one here. You would actually need to do that extra step, I think. I'm not sure if the max scheme just allows what I've done, but you know, you should be fine. Maybe. Find the area of ABCD. Okay, this is the part where I've worked out the lengths. Anyways, I guess you could kind of just say, well, they're different lengths, so you know it has to be a rectangle. Anyways, this line here, you're going 4 across and then 10 up, so it's square root 4 squared plus 10 squared, which is 2 root 29. Okay, this is also 2 root 29, and then just do the other, same thing with the other one. So this one here, you're going 15 across and then 6 up, so it's root 15 squared plus 6 squared, which is 3 root 29. We're doing this because this is a right angle triangle, so you're just using Pythagoras. You'll get that. So you just times these two together, and you'll get 174. Complete the square on this. So just factor out the coefficient of x squared to get that. Half this in the middle, and then square everything inside that bracket, but don't expand the square, and then take away whatever this is squared. Always take away regardless of what this sign here is. Distribute the 2 only to this one, so it's minus 25 over 8, and leave it here. And then that's fine, that's your answer. You could just say that c equals this whole thing here, or you could put it over the same denominator if you want, like that. Find the values of k for which this does not intersect the line y equals 3. Well, you can set them equal to each other, like this. Bring this to the side like that. Now, if they're not going to intersect each other, that means the discriminant is going to be less than 0. So b squared minus 4ac is less than 0. C is going to be k minus 3. That full thing is c. B is just 5, and then a is just 2. So just plug that in. You'll get this. You know, just solve it. You know how to solve this. You'll get that. A circle of radius 6 passes through the points 0, 0, and 0, 10. Sketch 2 possible equations of positions of the circle. You can kind of just... I don't know how I could, like, teach somebody how to do this, just other than just doing it. I mean, I don't think it's too hard to do this. Maybe the only thing realistically that you'd need is a little bit of time if you can't think of some way to do this. But you know, you can kind of just think to yourself, oh well, if I can do it on this side like this, then it must be symmetrical on the other side and pass through the same points. Find the equations of the 2 circles. Okay, did I get the sketch? Okay, so I said, okay, so what I've said is we've got a line intercept of 10 here. Okay, now this length from here to here is going to be equal to, if we just draw a line across this intersection here, it's going to be equal to that length there. So that means if we take these 2 points here, and then between 0 and 10, so that's a distance of 5 to get to the middle, right? 5 positions are just in the coordinates. This will mean that they have the same y coordinate, which is just 5. Okay, and so, you know, the formula for a circle is just going to be x minus a squared plus y minus b squared equals, their radius was 6, so this is radius squared, which is 36. I've just plugged in 5 because we know that that's the coordinate. That's the center. Okay. Anyways, just expand it, you'll get that. You'll get a equals plus or minus root 11. I plugged in root 11, just positive root 11 in there, and just expand. Not. Okay, yeah, never mind. Yeah. So I'm saying I plugged in root 11, positive root 11. Okay, well that makes sense because one of them will be on the right side, and then if it's the other one's just a reflection on the other side, it's just the same thing but a negative version of it. So you'll get these 2 equations for the 2 circles. You're given cos 15 and sine 15. Show that tan squared 15 is this. If you've done the EdXL Year 1 AS books, specifically the PO one, there's I think there's a challenge question that I've done. Maybe it wasn't even just a challenge question, maybe it was just a normal question. and it goes over how you can you know, deduce, well, solve what cosine 15 is and get this exact value, because it is an exact value. And there are a few ways that you can do it, but one of the ways, if you wanted to, is using the compound angle formulas. But you know, in that book, they show a different way. I do recommend that you go through the edXL books, even if you're doing AQA, because they are very helpful. Anyways, to get tan, and you're only given cos and sine, sine over cos is tan, so just do this divided by that. That equals tan 15. This cancels with that because this will just obviously come to the top, and then 2 divided by 2 is just 1, so you get this. We want tan squared, so just square root both sides. This root cancels, so you'll get this. We want it to be written in this form, so just rationalize the denominator, you'll get 7 minus 4 root 3. So we're expanding this, okay, and we're told some information about the coefficients. You get a formula for this in the formula booklet. It looks like this. Just plug it in. So what have I plugged in? Have I plugged in anything? Okay, never mind. I've just made this look a bit nicer. So this would be 2 factorial, and then 3 factorial, 4 factorial, 5 factorial. For some reason they write it like this, I'm not too sure why, but you know, it doesn't matter. The coefficient of x to the 4 is 1.5 times the sum of the coefficients of x squared and x cubed. So we can say that, what have I said? Okay, so that this here, added together, excluding the x squared and the x cubed, multiplied by 1.5 equals this here. Okay, so just do that. A way that you can think about it is well, x, the coefficient of x to the 4, so this, the word is just means equals, you can just imagine it as that, equals 1.5 equals 3 over 2, the sum of the coefficients of x squared and x cubed, so the sum of this and this, so it's 1.5 lots of this. Okay, that's one way that you can read it. I times by 24 on both sides. This reduces down with it mostly, so you'll get 12 times by 3, which is 36. You'll get this. I put this over the same denominator just to make it easier, and then I cancelled it down as much as possible, so this cancels down with that mostly, so you have 6 multiplied by all of that. And then what did I do? Okay, I think I brought this 3 further back out to this one here, like that, and let me see, what else have I done? Okay, never mind. Yeah, I've just distributed the 6 actually. Yeah, so this becomes an 18 and this becomes plus 6n. You'll have this. You've got n minus 1 in common on both sides, and then same with n minus 2. So I think I just cancelled down some stuff. Did I? No, it looks like I just expanded for some reason. It doesn't matter. Anyways, you'll get this. Okay, we know that n can equal 0, because we're told that it's greater than 4, greater than or equal to 4. So just factor out an n squared. Oh no, I just divided by n squared on both sides. You can only divide by n squared on both sides if you say this step here. And you'll get n minus 11 equals 0, so n equals 11. This is an optimization question. So we're told that the volume is 8,000. Okay. Another way that we can write the volume is pi r squared h. Okay, so pi r squared h equals 8,000. Okay, and what I'm going to do is rearrange for h. Okay, it doesn't, does it even matter? No, it doesn't actually matter whichever one you rearrange for. Makes no difference. It just depends on what your, it just affects what your upcoming steps are going to be. It doesn't really matter though. Okay, welding is time consuming, so she wants the total length of the weld to be a minimum. Okay, well, the length of the weld is just going to be 2 pi r h, so it's this circumference at the bottom multiplied by h. So it's basically just going to be the curved surface area of the cylinder. So 2 pi r h, not multiplied by h, but plus h, because we only want this like slither, not the full surface area, not the full curved surface area, because obviously if you've got a sheet of metal, you're not going to weld everything around it. You're just going to, you know, weld the 2 points where the point where it meets, that line where it meets. Okay, anyways, L equals that. We know that h equals this here, so I've just plugged it in to get that. I've said that r squared is just this multiplied by r to the minus 2. Now if we want this to be a minimum, one way that we can do that is, well, if we differentiate it, then we can solve for the minimum point. Okay, so differentiate this with respect to r, obviously. So there's 2 pi minus 16,000 pi r to the minus 3. You'll get that. Set it equal to 0, because for it to be a minimum point, it must be a stationary point. So set that equal to 0 to get this. I brought this to the other side like that. Yeah. And I've also multiplied by r cubed on both sides to bring that to there. What did I do next? Okay, so I just rearranged for r there to get this, and then r must equal 9.32. So this is the radius, which gives a minimum total length of the world, and then well, we know that the height is this, so just plug this into there to get what the minimum height is. This is the value of r, which minimizes L, by the way. Okay, we do have to show that it's the minimum, because it says fully justify your answers. So the way that we do that is, well, how do you prove something's a maximum or minimum point? You found the second differential, which is this. I'm sure you know how to do this step. That's why I'm just saying you do this step instead of actually going through that. You increase the power. Sorry, not increase the power by 1. Multiply by the coefficient, then decrease the power by 1. You know how to do this. Anyways, you'll get this. Plug in the r value here, and then this is 2.03. This is greater than 0, so therefore it is a minimum. We've got what is this? We've got trees in a forest, and we've got diseases A and diseases B. Now this is disease A and this is disease B, and we've got 2 different formulas for them. Now on January 1st, a total of 290 trees were infected by a fungal disease. Okay, and then in 2018, 331 trees were affected by fungal disease. Careful, this here says total, right? So 290 trees. This is the number of trees affected, and then this is the number of trees affected. Okay. So 290 equals this plus this, right? Because it's the total number. And also, I'm going over the thing when t equals 0, right? Because they start on they start in 2017, and then this result is also 2017, so it's 0 years after. Okay. Just plug this in, and then that in. That's fine. E to the 0 is just 1. E to the 0 here is just 1. So 290 equals A plus B. And then I did the exact same thing, but with this one. So 331 equals this plus this. Yeah, that's fine. You can do that. And then you can just solve these simultaneously now. I rearranged this one for A, and then I plugged it into this one here. And I think I just did some really boring maths to solve it. Just, go through that. Put it into your calculator, you get 90. Yeah, should that be equals 90, and then find the value of A. Just plug it back into this one here. You'll get 200 for A. Estimate the total number of trees that will be affected by fungal disease on the 1st of January 2020. So this is the total number of trees. Remember, it was NA plus NB with our values plugged in. It's 2020, so it's 3 years after 2017, so T equals 3. Plug that in, you get 434. I think this number here was actually a decimal. Just obviously just round it accordingly, because you can't have a decimal number of trees. Find the year in which the number of trees affected by disease B will first exceed the number affected by disease A. So yeah, just do that. I think this is disease A, and then this is disease B. So if you want this to exceed, if you draw the inequality like this and solve it, you'll be able to say, oh well, it's this many years. If you get like a decimal, you just round down. I divided by e to the 0.1t on both sides. I don't know why I've just repeated the same thing here. Divide by e to the 0.1t, and then I've divided by 90 on both sides, and then I think I raised this side to the power of 10, and then this side to the power of 10, because then this is just e to the t, and then I did natural log of both sides to get this, and you can bring the 10 down and just solve that, but anyways, you'll get 7.99 is less than t. Okay. The time in years is going to be less than 7.99. Okay. Also, you could have drawn the inequality the other way around if you wanted to. Just as long, yeah, it doesn't actually matter, because then you'll have t on one side and then whatever number on the other side. So yeah. Wait, does it actually matter? Yeah, sorry, yeah, never mind. It does actually matter. I don't know why I said that. Just ignore what I said. Actually, no, actually, to be fair, you could have just done it the other way and then just changed the logic of the question a little bit. Um, you can do like logical statement translations if you've had a look at stuff like the LSAT. Anyways, that's just going on a tangent. Anyways, the time is going to be less than 7.99 years, so it's, you just round down, so it's going to be 7. If you want the specific time, we've floored this. I did a video on floor functions in the step foundation support modules if you want to watch it. Anyway, so it's 7 years after 2017, so 2017 plus 7 is 2024. Comment on the long-term accuracy of the model. It's not very accurate. You can read through this. Fungus may die off, doesn't take environmental factors into consideration. After this many years, there'd probably be 0 trees, but model doesn't give 0. This is the stats section of the paper. Actually, we might have already reached the stats section, have we? No, that was probably just pure. Anyways, discrete random variable x. Okay, we've got these probabilities here. They must add up to 1, right? Because all probabilities add up to 100%. Sum them up, and then just do 1 take away whatever that result was to get what k is, so you get 0.16. The sum of x is 364, and the sum of x squared is this. N equals 10, find sigma, the standard deviation of x. Okay, well, the standard deviation, the formula for it is this, you're given it. Now here, we're going to be using this formula here, because we've got the sum of x squared, which we have. It'll be hard to work with this. Now, we've got the sum of x squared. Right, so we've got this part of the equation. Now, how do we get this one? How do we just get the mean squared without it being the sum? Well, if we know that there are 10 total things, this number divided by 10 will just give us the total of the means, right, without being summed up. So 364 divided by 10 just equals x bar, and then we want that squared. So just plug that in, you get 24.8, so it's this answer here. Nicola is a darts player. She's practicing bullseyes. She has a probability of 0.3 hitting the bullseye with each dart. She throws 8 practice darts, and using a binomial distribution, calculate the probability she'll hit the bullseye 3 or more times. So x is, if we call x the number of times she hits the darts, it's distributed as this. 8 is the total number of times she hits, and this is the probability of success, which is 0.3. We want x to be 3 or more, so x is greater than or equal to 3. If you're using a calculator, which you probably are, you can just say that that's 1 minus the probability of x is less than or equal to 2. Just plug that into your calculator, you get 0.448. If you're not using a calculator, not a physical one at least, you could just write out the actual binomial distribution for this. The actual bigger sum formula that I've shown in quite a few of the videos, especially when I've done hypothesis tests. Yeah, you could put that into Wolfram Alpha, you get the same answer. Throws 8 practice darts on 3 different occasions, calculate the probability she'll hit the bullseye 3 or more times on all 3 occasions. Well, the probability that it was greater than or equal to 3 is 0.448, and we're assuming that probability doesn't change on those 3 occasions, so it's just 0.448 multiplied by 0.448 multiplied by 0.448. So that's just this. State 2 assumptions that are necessary for the distribution you have used in part A to be valid. I've kind of just explained one of them. Probability of bullseye does not change. Events or hitting or missing bullseye are independent. This just means that this doesn't influence, hitting the bullseye doesn't influence missing the bullseye. Maybe she doesn't get nervous after she's missed one or something. This here, I was actually quite surprised to see a question like this. I've never seen a question like this before, but there's 3,200 students, and we want to survey them. We want to survey 60 of them. Describe how we can obtain a simple random sample of 60 from the 3,200. Now, the way that I said is just label each student with a unique number from 1 to 3,200. It's, obviously the number is going to be 3,200 because obviously the number is going to be unique because between 1 and 3,200 every number is unique. Anyways, though, use a random generator to generate random numbers from 1 to 3,200 60 times. So just pull up Google, just put in the limits 1 to 3,200. I think it is inclusive on Google, not too sure, maybe just check. Do that 60 times, get those 60 numbers, get those 60 students with their corresponding number, and then repeat step 2 if the same student is chosen more than once. This question here, I've kind of just shown the answer here if you want to look through it. It's not on the current spec, that's why I'm not going to go over it, but yeah. We've got a scatter graph here. Identify 2 outliers and want to give an explanation for each outlier. Now the first outlier here is going to be this person here who scored who got 80 with like barely any revision. That's going to be Collins. Sorry, no, not Collins. It's going to be who is it? Donovan. Wait, no, it's not Donovan. Okay, never mind. Yeah, this one here is Collins. I started off with Donovan on the right here. Okay. So he's practiced a lot, but he's not gotten like grades that follow this trend, because the trend here is that as you increase the number of revision, number of practice that you do, number of hours of practice, your result is going to be better. But his isn't necessarily like all the way up here, it's here. So he's an outlier. Maybe he's just not as good of a player as the others. That's actually an answer that you can put. Maybe he was distracted while he was playing. Maybe he just didn't really care about doing well in the exam. I think you can also put he's just naturally not as smart, which is the same as this, I guess. Anyways, the other outlier here is Collins. Okay, maybe he's been playing playing for a while before that week. Maybe he's just naturally smarter. Maybe not smarter, but better able, you can say. Maybe he's been playing for a long time. There are a lot of things you can say. Describe the correlation shown in the scatter diagram for the remaining points. So we're discarding these 2 outliers. There's a strong positive correlation. It's strong because you can obviously see that it's got like a very steep gradient. It's positive because it's going from bottom left to top right, and correlation is correlation. Interpret this correlation. I've already explained this. The longer you practice, the higher your exam score. This is the last question. So he's growing cucumber seeds. 0.7 all seeds successfully germinate and grow into cucumber plants. He wants to try out a new branded seed, and they're saying that they're more likely to germinate than other brands of seeds. He sows 20 of them, and 18 successfully germinate. And then we want to carry out a hypothesis test at 5% level of significance to investigate the producer's claim. Now H0, the initial hypothesis, right, is that the probability is just 0.7 of these new seeds, by the way, of the new seeds. Now the alternative hypothesis is going to be the probability that it's actually greater than 0.7, because they're saying that it's more likely to successfully germinate. It's just going to be greater than 0.7. Now under H0, we're going to carry out our hypothesis under the null hypothesis. We're distributing X, where X is just the number of successful germinations. Is this, so there's 20 total cases, 20 total seeds, and the probability of germinating is successful germinations is going to be 0.7, and we want to find that number is greater, because this is greater, that X is greater than or equal to 18. It's always just an equal to sign, by the way. I think I did a really bad job of explaining it in one of my first ever videos, but basically it's just because you want to test extreme values if you're doing the critical region method. Anyways, this is going to be 1 minus the probability that it's less than or equal to 17. Put that into your calculator, you'll get 0.0355. And then we're going to compare that to the level of significance. This is going to be 0.05. You don't do half of it because this is a one-tailed test, because we're only checking that it's more likely. This is less than the significance level, so therefore you reject H0 because there's sufficient evidence to suggest that P is actually greater than 0.7 in the new seeds. That's everything. Thank you for watching.